1, the Balloon Operations Center of the Air Force Geophysics Laboratory, AFGL, is the only operational balloon unit of the Department of Defense dedicated to research and development. Provides the Department of Defense and other government agencies with the most flexible and cost-effective platforms for conducting scientific experiments at altitude aboard either its low-altitude tethered balloons or high-altitude free balloons. The balloon detachment, located at Holloman Air Force Base, New Mexico, receives engineering and program management support from AFGL's Aerospace Engineering Division at Hanscom Air Force Base, Massachusetts. The balloon detachment, established in 1949 as part of the Air Force Missile Development Center, Air Research and Development Command, became an operating location of the Air Force Cambridge Research Laboratories, predecessor of AFGL, in 1961. The detachment has been involved in a wide variety of research and development experiments in support of national defense, space, and environmental testing programs. Among the notable space programs were Project Manhigh, a series of manned balloon flights above 100,000 feet conducted in the late 1950s to determine human reaction to a space-like environment. Discovery, the first parachute recovery of an orbiting satellite. Surveyor, the first moonlander. Gemini, Viking, and Pioneer. Among the environmental programs, Project Ashcan, conducted for the Department of Energy, obtained the first direct measurement of debris injected into the stratosphere from the eruption of El Chicon in 1982. The detachment's unmanned helium-filled balloons vary in diameter from 70 to 400 feet and can carry payloads weighing up to 15,000 pounds. Heights attainable range from 19,000 feet above sea level for tethered balloons and up to 170,000 feet for free balloons, depending on balloon size and payload weight. At Holloman, the detachment has a completely equipped weather station, machine shop, communication and instrumentation laboratory, parachute shop, and small environmental test chamber. Large payloads can be readily accommodated in its 1,200 square foot high bay assembly area. A thermal vacuum chamber large enough for most payloads is available at Holloman. Open-loop electronics testing can be conducted from this chamber to the detachment's telemetry station. Upon flight completion, the balloon and payload are recovered and the payload returned to the detachment for inspection and analysis. The balloon detachment also has access to the U.S. Army's White Sands Missile Range, which provides a modern array of tracking equipment such as precision radar, optical instrumentation, and telemetry, in addition to restricted airspace and excellent conditions for payload recovery. The detachment's balloon control and tracking center maintains fixed and mobile facilities for radio command, communication, telemetry, and in-flight tracking. Frequency and pulse code modulation systems are available with a variety of display and decommutation equipment. This decommutation capability offers the researcher immediate access to real-time processed data as well as post-flight digital recording. Data rates as high as 1.34 megabits per second and frame rates up to 10,000 frames per second have been successfully received, recorded, decommutated, and displayed. The balloon detachment has and continues to support a wide variety of research and development programs. For example, AFGL's BIMS payload carried heavy but delicate, cryogenically cooled instruments into the stratosphere to measure its ionic content. The result will enable the Air Force to estimate the effects of ions on low-frequency radio waves under disturbed conditions. AFGL also developed a pointing control system for balloon payloads in 1981 that has subsequently been used to coordinate air and earth measurements of infrared transmission through the atmosphere, data needed for Air Force detection systems. Detachment 1 simulated the controlled descent of the Galileo probe vehicle into the atmosphere of Jupiter for a NASA launch from an upcoming shuttle. The detachment also verified the proper functioning of Galileo's parachute and separation systems. Project Scribe, a joint AFGL University of Denver program, measures emissions in the stratosphere, the ozone layer, and the level of background radiation, critical for surveillance systems. The detachment is presently very involved with several strategic defense initiative-related programs.